Lesson number 1 in factors and products. Factors and multiples of whole numbers. Factors of numbers, or factors of a number, are numbers that multiply to produce the original number. For example, 2 and 3 are factors of 6, since 2 times 3 equals 6. Another interesting piece of vocabulary are divisors. So divisors are numbers that divide other numbers evenly or without remainder. So for example, 5 is a divisor of 10 because 10 divided by 5 is 2 with no remainder. So it's kind of the flip side, the dividing side of factors. Prime factors are factors that only have 2 divisors, one in itself. So, for example, 2 is a prime factor since only 2 times 1 is 2. Another example of a prime factor is 3, because 3 times 1 is 3, and that's the only way you can multiply to it. But an example, so we're going to say that 8 is not a prime factor, since you can go 2 times 4 equals 8. It has multiple factors, not just one in itself. So when asked to factor a number, we usually want you to do a prime factorization. Which just means break the original number down into a product of just prime factors. And we usually use a factor tree. Factor trees are very helpful ways of drawing out factors. So for example, write the prime factorization of 48. Well, if you know how to divide by 2, you'll be able to prime factor this number no problem. So we have 2 times 24. So these are kind of the branches, but I can't break down 2 anymore. Okay, I would just get 2 times 1, 2 times 1, 2 times 1. Okay, you can't break down 2 anymore, but I can break down this one a little bit more. I can say that is 2 times 12. And I can also break down 12. I can say that's 2 times 6. I can't break down the 2 anymore, but what I can do is I can break down the 6. 2 times 3. So if I wanted to get a prime factorization of 48, I'm going to say that we have 1, 2, 3, 4, 2. So 2 times 2 times 2 times 2. So just remember with exponents, that's just 2 to the power of 4 times 3. And that would be our prime factorization, because we have just prime factors. 2 is a prime factor and 3 is a prime factor. Another important kind of idea is this finding the greatest common factor. So we want to find out what the greatest common factor is between 72 and 120. Oh, and greatest common factor, we just shorthand it to GCF. So the first step is to find a prime factorization for 72 and to find a prime factorization of 120. And then we're going to figure out what is common to both of those things. Okay, so if I were to take 72, I would say that that is 8 times 9, sorry, I got distracted there. And what I can do here is I can say that 8 is just 2 times 4. I can't break up 2 anymore, but I can break up 4. That's just 2 times 2. 9 breaks down to 3 times 3. So what we have here is 2 to the power of 3, because I have 3 2's multiplied by each other, times 3 times 3, so that's 3 to the power of 2. Let's see how this next one breaks down. So I can go 120 is the same thing as 10 times 12. 10 just breaks down into 5 and 2. Can't break down that any further. Let's go to 12. We have 4 and 3. And the 4 can break down here to 2 and 2. So I have 1, 2, 3 2's at the end of all the branches. So 2 to the power of 3. And I have 1 3. And I have 1 5. So that is the prime factorization of 120. So let's just look at what's common to both of them. 2 to the power of 3, I see 2 to the power of 3 in both of them. And I see a 3 on this side. And I'm going to intentionally not highlight the squared. I have 1 3 on this side. So what's common? So I'm just going to write that down. Common to both. Two to the power of 3 and 3. 5 doesn't live in both numbers. There's no 5 there. And 3 to the power of 2 does not live in both numbers. Just 2 to the power of 3 and 3. So therefore, the greatest common factor is going to be 2 to the power of 3, which is 8 times 3. So I'm just going to write that 8 times 3, which is just simply 24. So that's the greatest factor that lives in both 72 and 120. Okay, so multiples are created when you multiply the number by 1, 2, 3, etc. And the multiples of 12 are 12, because 1 times 12 is 12, 24, because 2 times 12 is 24, 36, because 3 times 12 is 36, etc. It goes on forever. So remember, when we want to find multiples of numbers, this is exactly what you do when you find lowest common denominators when adding and subtracting fractions. And remember, you're pros at that. That's why you are here. So what I want to do is I want to find the lowest common multiple, or lowest, because it's not in a fraction context, we can't say lowest common denominator, but it's the same idea. What's the lowest common multiple between 8 and 6? So you would have done this probably in a similar fashion to this when you're doing when you're adding and subtracting fractions. You would say, okay, multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, da 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 da, and multiples of 8 are 8, 16, 24, 32, 40, 48, da 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 da. Now you're going to notice that we're going to see similar numbers, more than just one, right? I see the same numbers at 24 and 48, but the key piece here is we're looking for the lowest common multiple. There are lots of common multiples. I'm going to say there's an infinite number of common multiples, but when we write out the multiples of 6 and write out the multiples of 8, the number that pops up first is 24, so the lowest common multiple is 24. So that's probably how you did it when you're adding and subtracting fractions. How can we use our prime factorization or our factor tree to help us find the lowest common multiples? So let's find the lowest common multiples. It looks a little different when we have three numbers and they're a little bit bigger. Okay, so instead of writing out all the multiples of 18 and writing out all the multiples of 20 and writing out all the multiples of 30, which you can do, by the way, you would find the answer. Let's stretch our brains a little bit and use our prime factorization. So the prime factorization for 18, we start out by saying it's 2 times 9. I can't break down 2, so I have 3 times 3. Okay, so the prime factorization of this is going to be 2 times 3 squared, because I have 1, 2, I have 2 3's. Let's do the same thing with this, with 20. So the prime factorization of 20 would be 4 times 5. 5 is a prime number. I can't break it down any further. But 4 can be divided, or it can be separated out to 2 times 2. So the prime factorization of 20 would be 2 to the power of 2 times 5. And then let's check and see what the prime factorization of 30 is. I would write this as 5 times 6. I can't break down 5, so I'll say 6 is 2 times 3. So our prime factorization is going to be 5 times 2 times 3. So what we're going to do is we're going to multiply out. We're going to multiply out all of these numbers together, because we will find a multiple if we multiply 2 times 3 squared times 2 squared times 5 times 2 times 3. But it's not going to be the lowest one. The lowest one is when we don't when we take out the common factors. We don't repeat the common factors here. So I'm going to say that we're going to multiply them out together. So 2 times 3 to the power of 2. And okay, so with this one right here, I don't have a 5, but I have one of the 2's already. Okay, so I have the 2 living right here, but in order for me to introduce any new factors, I need to multiply this by 2. We're not going to put the 2 squared because we already have the factor of 2 when we multiplied the 18. Okay, and I'm going to say that 5 is not yet in the mix, because 5 is not a factor of 18, so we're going to multiply by 5. Okay, so now let's see here. Do I have my 5? Yep, so I don't have to multiply by 5 again. Do I have a 2? Oh yeah, you bet. Do I have a 3? Yes, I do have a 3. I have 3 squared, so I don't need to worry about adding another 3. So I have found I have multiplied all the factors together but not multiplied when they're duplicates. So 5 and 5. We're just going to put 1 5 down. Okay? So the way that I would multiply this out in my head is I would say 2 times 9 is 18. 2 times 5 is 10. I always love to find ways to multiply out to 10 because multiplying 10 by any number is so simple. So 18 times 10 is going to be 180. So that would be the lowest common multiple of 18, 20, and 30. Now, like I said in the beginning, if you would take 18 and write out all the multiples of 18 and all the multiples of 20 and all the multiples of 30, you would absolutely land on 180 being the lowest common multiple between those three numbers. But I wanted to show you how we can use prime factorization to find the same number. So, just in summary, remember that the greatest common factor is a number that's going to be smaller or equal, found inside the question numbers. Okay. The lowest common multiple is a number that's larger or equal and found outside of the question numbers. And when I say question numbers, I just mean like 18, 20, and 30. So if we're looking for the lowest common multiple, it's going to be bigger or equal to 18, 20, and 30. Whereas if we're looking for the greatest common factor, oh, that's funny. If we're looking for the greatest common factor between, say, a number like 72 and 120, our number is going to be much smaller. Factors multiply out to a number, and multiples are multiplied by 1, 2, 3, and 4 to produce bigger numbers. So we're going to compare the lowest common multiple and the greatest common factor of 8 and 10. So first things first, let's do greatest common factor of 8 and the greatest common factor of 10. So let's do that prime factorization again. 2 times 4, 2 times 2. So we have 2 to the power of 3. That would be our prime factorization. 10, we only have 2 times 5. So our prime factorization of that would be 2 times 5. So when I look at this list, there's no 5 on as a part of a factor of 8. So 5 is not part of the it can't be a greatest common factor. When I look at this one, I see 2, and here I have 2 to the power of 3, which you know just means 2 times 2 times 2. So the greatest common factor is just 2 between them. Even though there's 2 to the power of 3, there are 3 2's multiplied by each other to make the 8. Only one of the 2's is common to both. So like I said, greatest common factors are smaller. What about lowest common multiple? Okay, so I'm just going to use the prime factorization again. I'm going to say 2 to the power of 3, and I have, this one is 2 times 5. So we're going to say 2 to the power of 3. I don't have to repeat that 2 because it's already taken care of, accounted for with that 2 to the power of 3. But I do have to multiply that by 5 because that is not something that is a part of the prime factorization of 8. So 2 to the power of 3, which is just 8 times 5, is 40. Okay, so the lowest common multiple of 8 and 10 is 40. All right, time for you to do some exercises that are identified right here.